Okay, here we have a recap on Paleolithic tools and some of the cognitive and behavioral changes that we see from about 2.5, 2.6 million years ago. And what we're really interested in is the role that tools have played in shaping human cognition. Beginning with the advent of stone tools about 2.5 or 2.6 million years ago, we could at least say over the course of the last 2.6 million years, the development of our brain has benefited from a unique interaction with the environment. And again, this is very specific to humans. So we have old Dewan tools about 2.6 million years ago, and there we're seeing dexterity, motor control, modification of nature. And about 1.6 million years ago, Acheulean tools associated with Homo erectus emerges. And then we have our Mousterian tools that begin to appear. And we start to see axes and cleavers, spears about 600,000 years ago. So here you can note some of the connections you see in points, and I'll provide the slide at the end for a few minutes if you want to copy it. Anyhow, from Homo habilis, possibly Garhi, our relationship with stone has shaped human cognition. So, like I said, the Mousterian or Levallois tool tradition emerges, and here we have possibly quite advanced hierarchical thinking, intuition, and patience emerging, and then eventually what we see with humans about 200,000 years ago, some significant changes taking place in the brain. The relationship between motor skills, language, and abstract thinking is deeply embedded in the brain's neural architecture. Research suggests that movement and cognition are interconnected and share neural pathways, and both facilitate physical actions and higher level cognitive functions. This connection is evident in the overlap between motor control and language processing areas, as well as the role of fine motor skills in abstract reasoning. So everything here in the brain, it's connected, but in a way that motor skills have, or at least we think, have facilitated the development of these areas. The evolution of tool making then may have played a crucial role in shaping human cognition, driving the development of language and complex thought. Understanding these links provide valuable insight into how physical actions contribute to cognitive growth and language acquisition. The brain connects motor skills and language through shared neural pathways, particularly in the premotor cortex in areas like Broca's area, where the ability to plan and execute movements overlaps with the ability to formulate speech. So here in Paul Broca, who was an anthropologist, the area that he identified in the brain includes functions like speech production, facial neuron control, language processing, all of which is really important for our paralanguage and the kinesics that we use to facilitate communication. But this is also tied into our motor skills. So I'm here in a room by myself, and I'm recording this review of our material, and my hands are moving um, while I speak. So one of the things that we do when we talk, our faces are constantly moving. This is one of the reasons why a lot of us don't like pictures taken of us or videos, because our faces do really wild things that we're just not accustomed to. And our hands are always moving. And this is to facilitate communication to other individuals. So this suggests that the brain, it processes actions and language in somewhat an integrated manner, especially your ability to move. This is linked with our motor skills, and that's linked with our ability to produce language, and just connected with planning. It's connected with the way that we move. So Research shows that motor development can significantly influence language acquisition, especially in early childhood. It impacts the way that we act and, in the end, even the way that we speak. The brain connects motor skills and abstract thinking through shared neural pathways. So here we could visualize it as um, motor skills and abstract thinking overlap, jumbled together. And this is taking place in the prefrontal cortex, the cerebellum, and the basal ganglia, where areas for planning, motor skills, our working memory, reasoning, all allow for an integration of physical movement with motor skills, and this contributes to the development and the application of abstract concepts. So, it's not as simple as just having our various lobes that we've talked about. For example, our frontal lobe, our temporal parietal, our occipital lobes. These are interconnected. And I think evolutionarily speaking, one of the things that evolutionary psychologists and anthropologists have been exploring is, for example, schizophrenia. This is a condition that we find among humans. We can't speak to past humans, but it's not seen in any other species. And it's believed to be the byproduct of the acquisition of language. So schizophrenia is taking place in the same areas that's responsible for speech and processing language. Like I said, it's not as simple as having various lobes being independently responsible. Everything is interconnected in the brain in fascinating ways. The development of stone tools, then, it's theorized to have played a significant role in the acquisition of language and abstract thought by requiring complex planning, motor coordination, and communication to effectively teach and share knowledge about tool making, which likely stimulated the neural pathways associated with these cognitive abilities, potentially leading to their further development alongside of the evolution of language itself. Essentially, the complex cognitive demands of tool making may have acted as a driving force for the evolution of higher level cognitive functions like language and the development and the persistence of complex culture among our ancestors and ourselves. So, beginning with the stone tools, the development, that ability to look at something and see it as something else, right? It's not as simple as stripping a branch, for example, of the leaves to make a tool. Chimpanzees, for example, they do that. That is a type of object modification. But to look at a rock and see another rock as a hammer and anticipate that striking those two together and the right type of materials, for example, you're not going to create great tools or highly functional tools with granite to recognize, for example, flintstone or chert. These types of materials that flake easy, and in contrast, what a hammerstone is going to be, and then even to take a third tool, a third element, and include it, for example, the antler of a bone that could be used as a type of chisel to retool, as we see here on the edges of the Acheulean hand axe. The amount of planning, understanding of resources, abstract thinking, and motor skills that are involved to produce something that is this complex and quite honestly beautiful, was just a moment in human evolution that set us on a completely different path from any other ancestors that we had at the time. So there we have it. beginning with the advent of stone tools. 2.5 to round it off, 2.6 million years ago. I'm not particularly fussy about exact dates in introductory anthropology, but nevertheless, beginning with the advent of stone tools over the course of the last 2.6 million years, the development of the brain has benefited from our unique interaction with our environment. Again, in anthropology, we have to think of this holistically, and there is this tight connection with psychology. To understand the human brain, we need to understand our past. So for those of you that are thinking of exploring psychology, these are elements that we need to understand. And to be honest, we don't fully understand it. So we're exploring these areas. So we've benefited then the development of the brain from our unique interaction with our environment. Working from Homo habilis here, 2.6 million years, possibly Australopithecus garhi, to Homo erectus, to Homo heidelbergiensis and Neanderthals, and eventually Homo sapiens. Our relationship with stone has shaped human cognition.